Uh, right, Martin, I'm going to ask you to stop sharing just for one sec. Yes, hello everybody. Welcome to another episode of Amplifying F Sharp. For those who've never ever heard of us, let's quickly give a little introduction about who we are, what we do here. So let me just briefly share the screen. You know what? I'm actually not going to share the screen. Computer says no, but Amplifying F Sharp is a little initiative where we do live streams and we're trying to teach the F Sharp community how to contribute to open source projects. We've focused a lot on compilers and tooling, but we're open to other suggestions. And basically, I'm just gonna shortcut the introduction a little bit because I'm really excited about our guest that we have today. We'll have Martin, who's gonna present an implementation of a language feature he done in F Sharp. And you know what? Just take it away, Martin. Oh, classic internet thing. You were muted and started talking.
Of course. Thank you, Florian, for the introduction and thanks for having me here. And thanks for running F Sharp. For those who haven't seen it and were awaiting Florian's introduction, here is the link. And here are the sessions, and the session today is about scoped Nowarn, which is a feature that was requested for a long time for the compiler. And I've worked on it for the last half year and want to show a little bit what that means on the one hand. So a little bit of history, how such a thing works from the feature request to creating a PR. Then some technical background on the complications I came across and the difficulties. And finally, we will dive into the code and do a real review. So my goal is one, what the title here said, that it's a sort of case study to explain a little bit on what difficulties you come across when tackling such a feature. But also I want to explain the background enough so that it's easier to actually review this PR, and hopefully some people who are here or will see it later on YouTube can use this as a background to be able to review this thing because it's quite a big one. Any questions up front?
I feel
It's
like
like
I'm gonna ask a lot of little questions along the
great.
way. Like I
Yeah.
kind of to not spoil anything, I didn't really look into the entire implementation just yet. So I might ask some little things here and there. Is that okay if we just
Oh,
interrupt you, or
absolutely,
would you?
absolutely. Let's make it an interactive session. Yeah.
Yeah, all right, sounds good.
So let's start with like also was explained on the session page, the feature request. This is in this F sharp lang suggestions repository on GitHub. And this one is actually a quite old one. It was even there before this repository was there, 10 and a half years old. And you see that many people came across it and want to have it. Over time, lots of these F-sharp veterans were involved in the discussions. And at some point, it was approved by Don, approved in principle. And also somebody made a step towards tackling it by making a first rough summary of what it should do. Because if you just see the heading here, that when you first look at it, it seems clear on what it should do. But if you dive a little deeper, you see that there are a lot of questions that need to be clarified. This person it seemed wanted to go further than this, but first get some feedback on that first step, which didn't really happen. But I think that is also an important learning point that um, if you put stuff out that is not really ready, people know it's not easy to review it. You really have to dive deep into it, and nobody or it's a big step to dive as deep that you can answer these questions. That's why not that much came out of this. But I think theoretically it would be nice to do it in a funnel way, right? Have just a few statements like this, and then create a RFC, and then do the implementation. Reality is you typically have to do the implementation to understand it well enough, and then work backwards from there. Well, the discussion continued um, more F-sharp luminaries came up with suggestions. Also nice. I show this because it's a very nice case here. First, you see the discussion had converged here on the syntax on using no warn and warn on as pairs to switch a warning on and off. Um, um, But you also see here that this happens actually in the middle of an expression, of a match expression, right? So that is quite different from what we had before for no one that could only be put in a top level module. The discussion continued, more people shouting for the feature, and the team at some point was asking for contributor help, and I perhaps somewhat naively volunteered to tackle this. And well,
Well,
this is yeah.
I kind of like want to pause you there because it always interests me when you have discussions like this. It just does feel like a requirement to just go and try things in code before you can actually move the plot forward. And these discussions tend to happen with people who just only have like a part of the problem space in their minds. Like how easily did the conversation go there? Because at a certain point, once you go deeper, other people might just not have your learnings. And how did you balance that out? If you understand what I mean.
I actually so far had no opportunity to do, right? This is the first one.
Gotcha.
Because I created a RFC but didn't get much feedback on it for the same reasons that I mentioned earlier, right? I do understand that it doesn't happen. I would have loved to get feedback there. But except for one case that was actually coupled to another implementation, I didn't get much feedback. And that's why contributing can be sort of painful in that sense that you then do all the work, get no feedback, and at the end it turns out it was the wrong track, right? But that's a risk I think you have to live with. You cannot force the people to give feedback on those initial steps.
Yeah, I'm very happy that you bring this up because this is just something I'm like very familiar with in the Phantomist project. Like a lot of people have ideas, but once you go deep enough to see how that would actually work in code, then you just hit certain walls. And it's very hard to be, discussing these things once you went as deep as you did, and then you need to talk to people who just aren't seeing whatever like backstory of all this that you saw. So
I'm
I'm
sure this will still come for me, right? And that's actually why I was um, why I requested this session here to have an opportunity to explain the background, and then these discussions might be easier, or I could at least point them to this session.
Yep,
But
that's
absolutely, because also here you see it seemed to be already clear even how to implement it, right? It must be somewhere here. That's where it's being handled. But it turned out that was only a very small part of the overall problem that I had to solve in the end.
mhm, mhm. Yeah, I'm just very happy that we're touching on this side of open source as well. So yeah, let's continue. I'm very curious where this is going to go.
Um, it means, of course, also that I'm much more sensitive to requests like the one that I showed earlier and try to give feedback because I know now that when you are in that situation, you want feedback in those early phases, right? Okay, we were here. So I volunteered. I actually did also a first sort of proof of concept. Does it work, and do I understand enough? And then turned to the RFC. RFC is the spec of the feature. It's in this Lang design repository. But also here, for the same reasons that I mentioned, only a little feedback. Even after pointing to some items that I feel might still become contentious, right? Because, yeah, for different reasons. There's also a discussion thread here, so everything that is required in that process. I didn't talk much about the overall process. It's described in the F# repo also, or in the .NET F# repo, how that works. You first enter the feature request, then comes the RFC, and then the PR. Okay, to just continue on the history, we dive deeper into also the RFC later. Next step was then a draft PR, where I started implementing, right? And I had a first implementation that worked for implementation files. I found, of course, I have to do it also for signature files. So my checklist extended, right? Then I discovered scripts are differently handled, have to deal with it. Then a big thing I will come to about the line directives and how they interact with Nowarn and Warn on. That took several steps to get there. There we had a nice discussion actually with the team also. Then, like I showed in that example, we must be able now to place Nowarn and Warn on anywhere in a file. That's quite a change. Then I found that the IDEs react differently to it, so also, and they are handled via a different path. So all that had to happen. Typically, I would have concluded all of this and then turned this from a draft to a final PR. In this case, I instead created a new PR where I sort of started from scratch, pulling the features from that other one in there in 7 discrete commits, just for the purpose of making the review easier. One reason is this frightening number up here, where you see overall 975 files have changed. Well, about 950 are test baselines because the syntax tree has changed. But that means to look at all of them is difficult. So I split it into these different parts that all compile. The first one was also just adding functionality, so it still completely works with the old feature set. And then the last one works with the new feature set. So we have the PR, but that is of course not the end of the story. Now a review has to come, and there is still a chance that this will not really, in the end, become a feature of F#, even though it's so much requested, for a number of reasons. Once there are these items in the RFC that to some extent are incompatibilities, which is always a difficult subject. So that may be a reason that it cannot work. And the other is those changes to the ASD that will break the tools or need adaptation of the tools. And that may also be a reason that in the end it cannot land. So I guess that's something a contributor has to live with. And I must say, it was, even if that would happen, it was still a very worthwhile journey. I have learned an incredible lot about the compiler in this project. Any questions on this part?
Out of curiosity, did you keep track somewhat on how many time you spent into all this?
Not really, not really.
I mean, you probably wouldn't be happy if you knew the number, but it must be immense.
Yeah, it's quite some hours. But I'm in a lucky situation that I do this just for fun, and so I don't need to count the numbers, right? Okay, on the technical background, first of all, I'm really not a compiler expert and not a computer scientist, so please jump in if I start talking nonsense here, right? Which may happen. This is about switching warnings on and off, where we have this directive Nowarn today already, and we want to add now another one, warn on, to switch them on again, so that we have specific parts of the source file where we have that warning switched on or off. And this warn and no warn is a compiler directive, or pragma, something that most languages have. It typically starts with a hash sign on a separate line. And F sharp, the spec is mentioning three sorts of pragmas there. One is what is called here pre-processing directive for conditional compilation, if, else, and if, right? That is one. Then we have what is called compiler directives in the narrower sense. That includes the no warn that we are talking about here, but also these script-related directives that you know. And finally, we have the line directives that also play a role in this PR, where you can redirect sort of where error messages and debug goes for certain situations. To explain the complications, I want to go into a diagram that I've copied from and modified, of course, from the compiler overview. It is focusing here on the front end, the biggest part of the compiler with type checking and code generation, everything is just in this small box. Mermaid, which does this diagram, unfortunately doesn't have a gray out or dotted line box. We don't have a preprocessor in F sharp, right? But I still wanted this box here because I need it for the explanation. Such a project is also, to some extent, compiler archaeology, right? So looking why is stuff happening. I'm not sure. I have the feeling somehow that the lack of a preprocessor is also a little bit ideological, or sort of defense against requests for macros. I don't know. But this is the typical place in other compilers where you process those pragmas, because they are not part of the language, really not part of the source file that needs to be compiled, but just directives for the compiler. Since we don't have that in F sharp, we do it later in either the lexer or the parser. But just to go through this diagram, the source code flows into the tokenizer, and from there later into the parser. These two are built with the help of the tools fslex and fsparse. David has done a great presentation on those, also on available on Amplifying F sharp, which take a specification like these lexer rules, and this program turns them into a source file, which gets compiled and becomes part of the compiler. And similarly for the parser with fsyak. we have a special situation here that between the parser, the lex and the parser, we need another box, the that is called lex filter in the compiler. Um, that was initially, I guess, not there because F sharp was coming from ML and just a white space insensitive language that you could, where you could send the tokens to the parser with a context-free grammar, and it would just work. With the introduction, what was called at the time the light grammar, meaning these indentations, we need this in between. What this box does, it takes the information that is contained in those indentations, that you are now at a next level of the let statement or something, takes that information and puts it into additional artificial tokens in that token stream, and then the parser can stay a simple context-free parser as it was before. There is the parser creates a syntax tree. There is still a step after here that is important in the context that we are talking about that I will come to. Now to those complications that I want to mention. The first one is that this chain is a streaming sort of chain, right? The parser pulls at the end. When the parser needs a next token, it asks this lex filter, give me a token, and that one either has one in store or goes to the tokenizer, give me a token. And the tokenizer goes to the lex buffer, give me some characters. And if the lex buffer is empty, the lex buffer asks the filler, um, give me some text from the source, right? But uh, this is sort of cool and fancy. And I guess it was also necessary 40 years ago when you had 64K of memory. If you would do it today, I don't know. But that's what we have. And that means that with respect to those warn directives, if you have errors or warnings specifically in the front end here somewhere, including the parser, you cannot simply emit them because you don't have that information from the Nowarn statements yet. So what happens is that those warnings go to a special error logger that puts them into a separate stomach somewhere, like a cow, right? That ruminates and then later, and that's actually happening in this block here, regurgitates them and chews on them a little bit more and puts them into another error logger that then knows about the no-warn statements and can process them correctly. So that is one. Second is white space information. The original grammar of ML or F sharp didn't need to deal with white space at all. And also here, through what happens in the Lex filter, the parser itself doesn't really need it, but we need it in the IDE in the end. And I've tried to put that also into a picture here, where I'm not completely sure if it's correct. It's certainly simplified. That during lexing, white space, and I'm not talking about the simple spaces, which you can extract after parsing, because for every element in a syntax tree, you have a range and can find the spaces. But stuff like comments, XML comments, and those directives are collected during lexing, and then in this post-parse step are put or are collected for the IDE. Today they are put into the AST also as sort of global trivia. And as far as I understand it, this path is happening for VS Code, Ionite. And there is another path to do this for Visual Studio, which uses what is called service lexing to deal with these white space details. Oh, I have to show my. No, I don't see myself. My nice cup here.
Beautiful.
So that was another piece I had to deal with also to put those new directives through service lexing. So that is one. Another one is that, as I said, we don't have a preprocessor, so we have to do the processing of those directives in the lexer or the parser. For some, it's done in the lexer, namely for those preprocessing directives and the line statements. And perhaps I can quickly look into that because we will need it later. This is lex.fsl. So this is the specification for tokenizing in F#. And it contains a lot of simple stuff that you have names for the different tokens and so forth. But also processes those directives here. And that's just much more complicated as it would be in a preprocessor. Of course, some of the stuff stays. You need to know to handle the directives, and they can be stacked, or how's it called? There can be one one if statement in another one, right?
Nested, you mean?
They're nested. That was the word. Yeah. But there's also stuff that the typical lexer that ML would have had doesn't need, like this should start a line. There's no expression in the lexer rule, but what we do instead is that we check if the lexproof is really at the start of the line, and if not, we create an error and start all over, right? Sorry, here, not this one. Yeah, exactly. That's what we do. We create an error. And for the end of the line, we use a so-called continuation here. So use another lexing rule instead of the normal token rule to continue to find the end line and continue after it. And we also, once we are in this skipped part of the if and else, we have a completely different parser rule that also duplicates a lot. Anyway, this works and happens, and we will later see that we can do the Warn and Nowarn in the same way. The other directives are actually handled in the parser. So if we look in parse.fsy, we see here the piece where these hash directives are declared. The hash is just the hash character that the tokenizer sends as a token. An identifier like the one or the R for reference, and arguments. Perhaps here I should also show how this is translated by Eversyak into this parse.fs source file, because that is a nice example on how these line directives work. And if we go there, I briefly go back to the FSY. We have here this grammar piece, and then we have a piece that is actually source text. That explains what to do when you find such a piece in a source file. And that same piece of source we find back here in the .s file. And here you see the use of that line statement. The main purpose of that is really to be used in generated source code. And what happens is that if you uh, get a error here or warning, or you are in the debugger, what will show up is this is line 483 in parse.ssy. And this makes sense because you want to look into this file because that's the one you have created and not in the generated file. But the difficulty with the warn statement is that after long discussion, we found that the best way is to just look at the warn statements in this real source file. So if we go to the beginning of the file, you see warn statements here. Some that were put in by FSYAC, others that are copied from parse.ssy. And here you have the line statement. So we have here the Nowarn 64. If we put a little later here a warn on 64, but we are now in parse.ssy in terms of that line directive, what should happen, right? And in the end, the discussion with the team was you look only onto this this source file parse.fs. But that means we are here, if we look at these range structures that are at each element of the syntax tree, these range structures contain now pointers to those line numbers in parse.fsy. But for the Nowarn, we need the original line numbers and the original file. And that means we have to somehow remember those. And we will see later how we do that. So these are all the complications that I came across. But the biggest difficulty is really what I pointed out earlier, that in this example here, that the warn directives can now appear anywhere in the file, deep in the structures in an expression or submodule. And that means it can no longer be done by the parser. That is just impossible because you are somewhere where it's basically impossible to put it into the grammar, right? Because so far, those directives were just part of the grammar, somewhat artificially, I think. But anyway, this is a part of the F# grammar. And those directives are just next to other module elements like open statements and type definitions and so forth. But that means it can only happen at the top level, right? And that means now if we want scoped no warns, this is just no longer possible, right? And that means we have to go back to my little picture here. We have to pull the processing of those directives forward from the parser into the lexer, which in itself is not a big deal. As we will see, it's only a few lines change really in the parser and the lexer, but it means they have to be stored differently, and quite a few of small changes. Yeah, it also means, if I go to that extended picture here, that we have to store them a little different. During lexing, we can store them like it's also done for the other whitespace stuff in a storage that we have attached to the lex buff. In post parse, this is then turned into trivia, basically, for the whitespace. And that information about the warn scopes that has a whitespace aspect that goes into the trivia, but it also has this aspect of processing the warnings. After really researching how to do that, I decided to put that into the diagnostic options record. This is diagnosticoptions.fs, just a small file that shows here the diagnostic options as they are today. This is basically the outcome of all those different compiler flags that are possible. And this warn-off was also used for the Nowarn directives. And here we will see that later, two further elements that will carry that information of the warn scopes. So much about the difficulties. Any questions until here?
So you can wrap these things around basically virtually any expression, or are there like limitations in all that?
You can put it anywhere in a source file in a separate line, the warn directive and the no warn and the warn on.
But does it need to like encapsulate one exact expression, or can you
No,
even do
no.
it?
In this example that we had earlier, how do we have it? See here only that one case of the match expression is switched off for the warning.
True, but that captures an entire sin match clause, so that one I can understand. But can you, and this would be pure evil, but can you like after the if keyword do the opening Nowarn, and then after the then keyword do the close, and then it sort of
Sure. It doesn't matter so much because in the end it's only used to decide if a warning should actually be emitted or not. And I compare then just the beginning of the range of the warning with that warn scope that I have, and then it's either emitted or not, right?
right. So the warning, the entire flow of detecting the warning is all fine, but then it's more like a filter mechanism afterwards.
Yeah, yeah, yeah,
Gotcha.
yeah.
Yeah. Interesting. Thank you.
Actually, that part is not so different at the moment, right? You can put the yeah, it is because you can put the no one only in the top level module, right? So you have no chance to put it into an expression. But the way it's working is filtering basically.
Mhm.
Okay, then let's quickly look into the RFC because that is an important piece of the context. This is how a RFC looks. It's a PR here still, not approved, as I mentioned. With pointers to the original issue, the implementation, and the discussion thread. Motivation, which I've taken from the issue comments that I showed earlier. And this is the specification, really. So first, we have a new compiler directive warn on that we have to add to the spec. It has the same arguments and so forth as no warn. There's a caveat that I perhaps skip in terms of time, but which may be contentious. Then the warn and no warn are always pairs. So in the beginning of the file to the first directive, you have the default values that are determined by the compiler flags. And then if there's a no warn, it just means that thing is now on until the next off until the next one on, or vice versa. And in the end, if it's then not a pair, but just a no warn, it's valid to the end of file. If it was a pair, then also after the end of the pair, you are again back to the defaults. Then, of course, it must appear now not only in non-nested modules, but anywhere. This one says this is all true for implementation files, signature files, and scripts. Scripts is also something that would be a breaking change. So also something that needs to be discussed, and I haven't had much feedback on it yet. FSI should not be a problem. And finally, about line directives, we talked about that. So that would be the specification. there are alternatives discussed, compatibility, diagnostics. There may also be feedback that it should be a little bit different, but that shouldn't be a big problem. And then tooling, of course, and the breaking changes that this would introduce. So that's the RFC. Yeah, and then we have the PR that I briefly showed already. And if there are no questions right now, I would jump into actual code. I would first go into that first commit here, which adds only stuff without still changing the functionality of the compiler. That's the feature flags, tests, and this core module warn scopes. And this is the signature file here of that warn scope module. It's a no new source file under syntax tree. And this is basically the API to that module. Not very difficult. We have two functions here that are called from the lexer when the lexer finds a warn directive. This is the main one here, pass and register warn directive. So that in this warn scope module, this line is then passed and stored away, which warnings are here switched on or off. And for the reasons that I've mentioned, we also need the information about the line directives. That's why we have this function register line directives. So those two are called by the lexer, and we will see that in a moment. Then we have here function merge into. That's called in that post pass step. And in this function, everything that we have stored during lexing, which came from these two functions, all of that is being processed into what I call then warn scopes and put away into the diagnostics options that I showed earlier, called merge into, because the diagnostic options stay during the whole session of the compiler service. So for every file we have, in post pass, this function would be called, and the warn scopes of that file would be added to those that are already in diagnostic options. You look like a question, Florian.
Yeah, I'm already a little bit jumping ahead, but I was like thinking what would happen if you want to like have these things they have in, well, the warrants are in weird places, and then we kind of format the file. I'm already kind of thinking about what happens there. But I'm jumping a little bit ahead, so I don't know exactly how you're storing them in the syntax tree.
But
And
after formatting, you would anyway compile again, right?
well, after formatting, you need to reinsert these warn directives
Oh, you are
that go
thinking
to.
of Phantomas now.
Yes, exactly.
Yeah, yeah. That's shouldn't be a problem because there are two things. First, it's stored here in the diagnostic options as for the actual processing in the diagnostics loggers, but also they are put into the global trivia, like where you also have the XML comments and the
Well,
comments.
the information is stored there, but we have the
And
same problem.
you
We
can
have the same
reconstruct
problem.
them. You can reconstruct them from that information.
Yes, but it's easier said than done. Like in certain cases, when you put a comment in a very, very weird place where we not expect it, it's might not show up after formatting. So I feel
Yeah,
like
I
this
see
would.
what you mean. So you probably have this exactly the same issues as you have with comments there. Yeah.
Yes,
Like
that's like my first guess.
one example would be if the formatting would change the lines, we just can't copy paste the AST information with the no warns into the formatted code because the lines could have changed. So we really need to do something more to get the regions correct, because we are basically targeting regions and not lines, I guess.
we would sort of need to like pick a close neighboring node of the Nowarn and then just sort of
Mhm.
assign it. And if we drop the ball there, you would probably miss one of those pieces. The same happens with comments as I mean, it's gotten a lot better, but it can still like in theory happen. So I was already kind of wondering off like how that story is going to play out.
Yeah, yeah,
Sorry about that.
no problem. Yeah, I was in one scopes. So that happens in the middle there in post pass, and then when it's actually used by those diagnostic loggers when filtering the warnings, here are just two functions: is warn on or is no warn? Is this in a scope between a warn on and warn off or not? So that's the API to that module. And if we now actually look into that first commit, right? We have, as I mentioned, all these different commits. And the first one is just, as it says here, adding the feature flag and some baseline tests and that one scope module. Here I had to add this file to the nullness section of the Fantomas ignore, right? That's a section that really should be, that whole section probably be removed now as soon as Fantomas can do the null stuff, right? That was all here. Then we have the release notes for both the service and the language. We have the name for the text for the feature and some new warnings that have to go into fscomp.txt. We have the new modules in the project file for the service. Here are the diagnostic options. Yeah, as I mentioned already, I got a first review this morning and some questions. But here you can see what I added here, right, to what I showed earlier. That is a flag that tells me if you're actually dealing with warn scopes or if it's an earlier compiler version. And then just a place to put those data or store them or make them accessible, the data that I was talking about. So in that post pass step, they would be connected to this place so that we can access them later in the diagnostics logger. And I understand that it would be nice to keep it immutable. I think there are good reasons to do it that way, but that needs to be a discussion that would still happen. That's just the FSI file for it. The language feature is all stuff that happens like with every new feature that you add a feature, it appears in a few places. Here is a file access store that contained all the code that accesses this special place called buffer local store. That is a just a place in LexBuff where you can store stuff during lexing. This is done like with XML stuff, comments and other stuff. And I'm only here moving the basic access to this a little further up so that I can make use of it in one scopes. I'm actually making it an extension member of LexBuff. And that's the FSI. Here I only came across a typo that I checked. Here is the what I just talked about, access to that those local data. Just a member to get the data. That is all that needed. Here's a second virus try-get. This one provides an initializer so that you get initialized data back when it doesn't exist yet, and this tries to get it. And that's what used by these different elements and also by the one scope module now. That's the FSI related to it. Then I have a new test file that contains like 50 tests or so. And in view of time, I won't go into those. Oh, sorry, no, that was the one scope file itself. We will go into that in a moment. The one scopes.fsi we looked at earlier. And the rest is really about like these translation files and testing. So perhaps I leave it with this for that first step where about that one scope module, except that we have to look into that module itself. It started simple, but then in the end still got like 370 lines. But I hope it's well structured. So we have this temporary storage in that Lex buffer. There we just store the directives more or less as they are, meaning we have a range and we can have a comment after that, no warn or warn on. And we have a list of warn command. Warn command for me is just the warning number, the range of that warning number itself, and it's either no warn or warn on. And when the Lexer says I have found something, it's put in this way in that local storage. Same for the line directives. They are stored here in a certain format. And here are these functions that are called by the Lexer register line directive, where I store the original line, which I can still find in the lexbuf, right? In this file, in the case of parse.fs and fsy, it would be the original line in the parse.fs, right? And the line I get here in that function call is the new one in the .fsy. And I store that information and also the file index that belongs to it, so that later I can go back from the FSY to the FS when I need it for the warn scopes. Then this is how I'm not sure if the heading is correct. Let me see. Correct, this is correct. But this is not the right heading here. I have to change that actually, because what this is doing, oh, sorry, it is. Yeah, this is this parse and register warn directive, exactly. We had above, we had the line stuff, and this is the warn directives. So here I just get these data that are attached to the lexbuf, create the warn directive, and write it back, append it to those that are already in there. And in between, I have to parse that directive. It's just a line that I find here in the lexbuf, and I have to parse that directive. And that's what's happening here. And I perhaps shouldn't go through that. I do the parsing with a regular expression. The numbers I detect like they were detected before, so we can or cannot have quotes and the FS prefix and a lot of specialties that were already there in the current version of the compiler. Okay, so we have both the line and warn directives now in the temporary storage, and now in post parse, we have to process them and actually create what I call then warn scopes. That relates to what we have in the spec in the RFC, that we have on and off warn scopes. These are pairs of warn on and warn off directives for a certain warning number, right? And they have a range from that one state directive to the other. And when it's not a pair, but going to the end of the file, then we have a different case here in that union. Then in the diagnostic options where I store it for later use in filtering of the warnings, we have this data structure warn scope data that includes these warn scopes, just a map actually of all these warn scopes, and those line maps which map from the redirected file to the original file. So these are the data structures, and then there is, similar to accessing those local data in the Lexbuf, I have here function to access the data stored now in diagnostics options. So every access to it goes through these functions. Again, with a version here that creates an initial file and one that sets it back. I did it that way because in the order of files, the diagnostics options are very early. And I didn't want to define those data types in that very early file that is needed in the whole of the compiler. That's why I am doing it just with an object pointer in diagnostics options, use these two access functions, very similar to it, like it's done with the local data and the Lexbuf. So these are the data structure and the data access, and this is how it's really being done then, this merge into function, which takes the directives, which is just the one on and one off, and turns it into those warn scopes, into these definitions of pairs or open warn scopes. And I guess I will skip that right now because that is something one can just go through. And finally, we have these two functions, is one on and is one off, which take a warning number and the range. They take a warning number and a range option actually, so that in the diagnostics logger you can look at a warning, which has a certain warning number and a range, and you can send it here to check, is that now inside such a warn scope? That is the core functionality that I added in that first commit. The second commit, I see we have an hour, Florian. How do we deal with it? Do we do a bit more or stop here? Or?
I'd say we do a little bit more. Feel like we're building up to something,
Good.
so that
Yeah.
might be maybe a lot of fun.
Okay.
Maybe just one little question before we jump
Yeah.
ahead. You seem to be doing some parsing about the actual line that's coming in to detect the numbers and whatnot. And you mentioned a regular expression. I'm a little lost how that's not happening in tokens in the tokenized phase, or is the individual line not tokenized?
I guess
or?
we right now come to it because that's what I wanted to show here in commit 2,
Oh, gotcha.
changes to lexing and parsing.
Yeah, go ahead.
We skip the service lexing, I come back to it. And also the FSI of it, and look into lexing. There are two places I changed a little. One is where the line directives are being detected. So that's how it's done today. And I basically edit just this one line here where I call this register line directive function that we discussed earlier. This line is just extracting the file index out here because it's used by both. So basically this one function call that I'm adding here, so that next to what happens anyway with the line directives here to change the line numbers, we also register it there so that we can later on map those scopes back. The other change is here, and perhaps that is where the directives are actually or detected right now, and perhaps I go into the file itself so that we can really better see it. This is around line number 1080. I briefly showed you this endif stuff earlier, right? And then here we have what I added to the Lexer next to that one line change in the line directives. So we detect here no warn and one-on warnings, similar to how we do it up here with the if and end if, right? So this is the Lexer, and that means the pass here, like with the if also, there can be white space before, and then this directive. And then anything after, we again have to deal with line end by discontinuation here, right? And we also have this should start line. So that means effectively we have a single line that has space and then the directive and anything after. And that's what we actually send to here with this function call to the one scope module.
So that's what you're processing, like the any string is what you process a little bit by with the regex that you showed earlier.
Yeah, exactly. Yeah.
And because it's just too difficult for just like pull into like a grammar rule, or was it just more convenient, or?
Well, we are in Alexa here, and as I explained earlier, we have to do it in Alexa, not in the parser.
Yeah, I was just talking about the Lexing grammar rule, so to speak. Like
Yeah,
you.
what we could do if we go a little up here to how the line directive is treated. Let me just see. Yeah, this is where the line directive is treated, right?
Mhm.
And there actually this line is being parsed, which is quite complicated to do in the Lexer because you have to pull in those
Oh, I
new
see.
words and tokens, right? So you
Mhm.
can do that, but it's quite complicated compared to how I can do it when I just get the full line as I have it
Yes.
here, and then do the rest separately.
Mhm.
There are these complications that we have everywhere, like for the sake of the service lexing, we have, oops, sorry, it happened here. For the sake of service lexing, where was I? What was the line number? 1081.
1077.
How did I jump here? Here we are. For the sake of the service lexing, I have to send a token just for this case here where the skip is, I always have to think where it's off. I have to send this token into the service lexer. During normal parsing, that does not happen. Then I just continue with that end line here. Yeah, and the line continuation I also have to do very similar to how it's done for the if and end if statements. So this is the addition to the Lexer. And then going back here. So this we have dealt with. In the parser, it's even less. This is the new token that the service lexing needs, right? That appears in the, or has to be defined actually here in the parser. And then I have removed this comment here from the place where the hash directives are passed because it's no longer true. But the parsing of the hash directives, which I showed earlier, perhaps we can very quickly go back there. Here, except for that this piece is no longer valid about the no-ones. This stays the same. So this hash R and hash I and so forth for the scripts are passed in the same way. Only the hash no-one and hash one-on don't get here because they are met by that Lexer rule before we get there. So that's all we have to do in the parser. And the rest is, again, baselines here in the surface area. We have that new token, and that's it. So that was the second one. Does that also answer the question you had earlier?
Yeah, it does. It does.
Okay,
Thanks.
great. Then I've done a next step here that removes just all the, what I call your legacy processing, all the previous processing that came from processing the one directive that came from the parser. And that one thing is this error logger. That is the one, that second stage of error logging where you, I think I really should go to the file itself too, so that you can see it. Right at the end of this file. Why does Control End not work? End works, okay. So yeah, this is also bad because it's the changed one. Sorry, then let me go back to where we were here. This is, perhaps I have to extend it here upwards. Yeah. So here we are. This is a diagnostics logger that was called diagnostics logger filtering by scope pragma. Scope pragmas was the data structure that was used previously for those Nowarns. By the name, I guess that somebody long time ago had the intention to make it actually scoped, but it was used and actually only for those open-ended Nowarn directives. What changes here is basically the name. I've called it now. It's up here. Called it now. Same thing, but with scope no-one in the end, and that it has different parameters here. This needed also those scope pragmas. That information is now in diagnostic options. There was also a funny flag that said, really don't use the scope pragmas most of the time. Yeah, and then the processing here actually of the scope no-one is removed here because that happens now in this adjust severity that I have here, right? So that happens now a little later centrally in that place where also all the compiler options are processed. That is just the FSI file related to it. Then a big one is this one, parse and check inputs. That's where, say that's the umbrella around the parsing that contains also this post-parse step. There we had functions like get scope pragmas for hash directives. Right, that's what now is in my merge into, where the hash statements are taken and are converted into something that can be used by the error loggers, but this is now done differently. Same here for the signature files. Then we have changes here because we don't need the scope pragmas, so it's only an empty list here. In this step and in all the steps in the first 5 commits, I didn't change the structure of these data structures. Because that immediately gives that whole, those 900 BSL changes, right? That's why I just have then empty lists in there. Again, scope pragmas, that's all related to it. This is now in the midst of where the parser is called. Go a little bit further down here, and then we see that here, that is the call of the parser, because the parser has this function implementation file, and calling that function means parsing the input according to the grammar that is behind that function. And the same then a little later for the signature file. Here, nothing really has changed except that we can simplify that. Here, the result, the input, needs to be stored in a variable to use it then at this point a little later, just to get something out of it. Yeah, to get or to put the scope pragmas into it. So the scope pragmas are now made part of the AST basically, right? Which is a little questionable because they are really just meant for the error logging and nothing else. And as I store that now in the diagnostic options, we don't need it here. So the rest stays the same. Yeah, you will see here, for example, that oh no, this is an error logger, and we don't need the one we discussed earlier, right? And we don't need to put the flag and the scope pragmas into it anymore. This is also an interesting function here, process meta commands from input. That really looks like somebody was proud of, you know, sending functions around and making it a little complicated. This processed a number of things in parallel, the warn directives and the hash reference directives and the load source directives, recursively through scripts that have them in there. Yeah, we don't need, if we stay with the spec as we have it now in the RFC, we don't need to do it for the warn directives anymore. So that whole all becomes just a little simpler. Yeah, that is all related to this. Yeah, that was parse and check input and the signature file related to it. Scripts are a special thing. I mentioned that in the RFC. I propose to handle scripts now in the same way as normal source files. Right now, actually, with that mechanism that I just pointed to, all Nowarns are collected from all the scripts that are called in a load. And that means if you have somewhere a Nowarn in a included script, that is also valid for the script you are just in there. I yeah, just don't know if there is any content reason for it, but in any case, if we change that, it's a breaking change. If we don't change it, then there is really no good way to deal with warn and no warn. So I see these two options, either have a breaking change or say that in scripts you don't have that new functionality of warn scopes. Yeah, here you can actually see how this warn off was handled in the past by, at least for the scripts, by putting it into tcconfig v, or call this function, which actually puts it into the diagnostic options that are also part of tcconfig. Scope pragmas we can remove. Yeah, and then FSI is again a whole different thing where it's processed in a different way. I don't think I will go through there, but also there I removed the old processing. So that after this step here of commit 3, we can still compile the compiler, and it also still works as a compiler, but it doesn't do any Nowarn processing anymore. Now, the next step is to integrate the new functionality. Let me see what are the most important parts. Yeah, this is where actually this adjust severity that we came across earlier. This is where this filtering of warnings is done. The way it exists here is already due to an earlier PR that I made. So I had prepared it in a way that adding the new stuff, yeah, which is calling this is warn on and is no warn, that this is an easy insertion here. So in that whole logic here, this is the filtering logic on when a warning is an error or is a warning or is no warning at all and so forth, all that logic. I had only to make some simple adaptations that call these new functions is warn on and is no warn. So that was, I think, a good step to prepare that in a separate PR. This is in file options, not that important. In parse and check input, where we now integrate the new functionality. Here is a function collect code comments. That's where comments collected in Lexing and also those triple slash comments were put into this data structure. And let me see. The only thing here is that these triple slash comments were taken out of that store here one level higher in the post parse, and I just simplified here. So that's not important at this point. Here is a function that I needed to add get submodule ranges, just for the sake of creating legacy error messages if we are in a old compiler mode. So if we have language version that is before the introduction of warn scopes, we have to create the same error messages that we had before. And that means if we have a no warn or warn on inside a submodule, we have to create an error, and therefore I need these ranges, and I process them in the warn scope module. And this is where this central function merge into out of the warn scope module is called with these ranges that I just mentioned, and the lexboof that contains the temporary data. Here we have the trivia that are so far just the conditional directives and the code comments, and later we will add the warn scopes here. Yeah, I think these are the most important parts for now. Here, just the same is again happening for the signature files. And I think that's for now. And FSI, I also don't go into at this point. I would rather go into this one here, adding warn directives. This was to the trivia. This was something.
Before you start the next one, maybe you have already mentioned it and I missed it. But is there a cross check between warn no warn directives between the signature file and an implementation file?
No.
Okay.
should there be? I thought, are they
No,
not
no,
just
I'm
independently?
yeah, I'm just
Yeah, no, there
asking.
is not. No, no.
Okay.
I became aware of that whole trivia part, or that say that it's related to what I'm doing here only rather late. But it became clear to me that I had to add information about those WARN directives into the trivia. And that's what's happening here. In that first step here, I put this in here. So in this structure here, past implementation file input trivia, there are the condition information about the conditional directives and the code comments, and I still commented out, put then information about the WARN directives there. I haven't activated it here yet for that reason that I mentioned earlier, because it would immediately introduce 950 baseline changes, right? And I wanted to keep that back as long as possible and do that only in the next step. But that's where the information for the IDEs is landing about the WARN directives, so that they can be colored in the right way and so on. At the same time, I have, instead of creating that structure here, an empty structure here, I have defined that up there and can use then this parse so forth empty. That in the next step, I don't have to change that and touch it anymore. So that's the main thing over there. And then again, FSI and also stuff in the incremental and transparent compiler and so forth that I should perhaps not go into. This perhaps important still that what I used above in syntax trivia, I defined this structure to just keep the complete information of the directives, so that, as I said, the IDEs can use it later for coloring and so forth. Yeah, I think that's the main stuff.
You store these things as an int list, but that's not necessarily how they are represented in the source code, right? It could be like a string list of fs and the number, comma.
Yeah,
That-
it's like also with the other items here, the conditional directives and the code comments. It's just the information so that the IDE can work with it.
Yeah, but just like from a Phantom's point of view, we would use the range and select the thing from the original source code. It's going to be more accurate versus than what we find in the actual numbers.
Yeah, let me see, but I think where have I defined it? You have here the range of the whole WARN directive, so you can find that way back, and the WARN numbers. But if there's something missing, I should
But
still add that.
there's nothing necessarily missing. It's just that the int list itself cannot be trusted as the single source of truth for what the user actually types. Like the range and getting it from the source text is the source of truth.
Yeah, true.
Yeah.
And you would like to leave it that way, how the user typed it, right?
Yeah,
You do
exactly.
not.
If somebody
Okay.
typed Nowarn FS
Yeah.
something, then you probably want to restore that similarly after
But then I
formatting.
guess you can just ignore the int list and just take this range and the text of that range, and then you have the
Yeah,
original.
yeah. There's a solution for this, and it's the same for blind comments. So it's not. I'm just double checking. Like
Mhm.
that's.
Yeah, yeah,
Yeah. No, it's all good.
yeah. And those last two commits just like here remove the comment here, so that line directives are actually there. But that means immediately, if I scroll down here, that I have all these baseline changes, because the AST contains now this additional field here in that data structure, right?
Did you
And
also add like new tests to this?
I have what I showed in the very first commit, a new test file with some 50 test cases or so about the Nowarn scopes. For the baselines here, I'm only changing the baselines.
Yes, but do you have new files in this test service data syntax tree folder? Do you like have new F# files in there? I might have missed that.
No, that's a good point. That should probably still happen. Yeah,
It's very invaluable
yeah,
that you
yeah,
just if you change the syntax tree that it's somehow
yeah,
reflected in a new
yeah,
file in there. That'd be
yeah,
great.
yeah. Makes sense. Yeah, perhaps I'm too fast. Yeah, perhaps really for the one on because that wasn't in there before. Yeah,
Exactly.
yeah,
Yeah.
yeah, yeah. And because it can appear in different places now. Yeah, absolutely. So that's a good point. That last step here now removes like this scope pragma here, where I so far only replaced it by empty lists, removes it from this data structure, which means, of course, even more changes where do we see it in the baselines? Yeah, here we had in the commit before the empty list, and that disappears here, right? I think this is the most important pieces perhaps that hopefully would enable people to review this PR. I hope it was useful. I hope also there will be people now that actually review it and bring this forward, and that we get through these remaining discussions that certainly need to be led and will lead either to a new feature or to the conclusion that that it's just not doable in F# if we want to stay compatible with the past.
All right. Thank you. Are you ready for some nitpicks? Because I mean,
Oh, absolutely, yes.
this is a code review. So,
Yeah.
do you have any sense of whether performance in parsing and lexing is affected by this?
I can't imagine that it is. I haven't made benchmarks, right? But in lexing, you have only in case an actually one or no one statement appears, you deal with it, but that should be really if I think through what happens through lexing and in that function that I call, that is so little that I cannot imagine anything happens there. And in pathing, nothing happens at all there. It's only less because the no one doesn't even get there.
Mhm. Well, I mean, it's going to consume a little bit more memory because it's carrying some of the stuff, I assume. So, um,
Which,
well, I feel like the diagnostic options you sort of pass a little bit
true,
more.
yeah. Overall, in the compiler, we use a little memory,
Exactly.
but then therefore the other stuff like the previous scoped pragma structure disappears. But
Mhm.
it, of course, because of the new functionality, there's also some new data. Yes.
So we have a question from Tim. I admire your patience doing this understanding compiler design. Did you have previous experience working on compilers?
Actually, the first experience coming close to compilers was when I came across some post of yours, Florian, about um, the SIG file generator. What's it called again?
Ah, Telplin, yes.
Telplin,
Wonderful.
right? And I found that interesting, and I thought it's perhaps easier to start there than just immediately go to that big thing of F# compiler. And I looked
Mhm.
into it and even made a PR there on something. No, that's how I got to it. And as I said, I'm not a computer scientist. I just enjoy diving into it and enjoy dealing with complex stuff.
Yeah, that's actually an interesting thing you bring up there. There's like a lot of, well, I guess just projects overall, just using the F-sharp compiler service, which has your first hooks to the compiler without, necessarily needing to dive into the actual compilation just yet.
Yeah.
So there's indeed a lot of learning things there. Um, One other thought I had, yeah, so there's a little bit of magic involved in the fslex and fsyak. So if your FSL, FSY files to have like the correct line number thing going on, I'm kind of wondering, is that worth it?
Good question. We had a discussion about it. I first had a very complex thing in mind that the no ones in FSY are valid only there and in FS only there. Then Tomasz actually proposed, is it worth it? And we just uh, don't allow it or ignore it or something, right? And I
Mm-hmm.
readily said yes to that because I agree. But then there was further discussion, and Kevin said, "Well, it's possible to map it back, and why don't we do that?" And that's what I have implemented right now.
Yeah. Yeah, that's interesting. Like if it's indeed is possible, then might be some.
Yeah, actually, it has a few caveats, right? Because
Hmm.
um, uh, you only have that information. It's from we are now in that FSY file. Um,
Hmm.
and the last time this was uh, actually lexed, it came from that FS file. But assuming two FS files point to the same FSY, then you have a problem, right? Because you
Right.
can't map it back. And in this case, I emit a warning, but that anyway shouldn't happen at all, right?
Yeah, exactly. Um, yeah, that's it's very interesting. And then do you, I guess, to like further sell the idea to the F sharp team, have you created like a good example, like where in practice in a real world F sharp piece of code would this be like relevant?
Well, I think there is enough information for that in this in the issue, right? The use cases that are also back in the like this one, but a lot of other examples here, and also in the RFC under motivation, there are all these examples why.
Sorry, let me rephrase that. Are those examples like ported into like component tests? Did you go that extra mile?
Not these exactly ones, but all the different use cases. If it's in a top level module or in a submodule or expression, and in which order you have the Nowarn and Warn, if it's in scripts or source files or SIG files, that is all tested. There are like 50 tests in that big test file. Yeah.
Gotcha. So like all the code paths really are tested.
Not all, I guess, but quite a
I
few of
mean,
them. Yeah.
it still is the syntax tree, so you'll never cover it all, but
Yeah.
exactly. Like, yeah, cool. Very, very interesting. Suppose this all lands merged. This is just an F sharp 10 thing?
An F sharp.
10 thing.
I would hope so. Yes. I mean, if we can come to agreement that it's worth it, right? But
Hmm?
as I said, I would also understand if the conclusion is we cannot do that. It's too creates too many breaks in tooling and so forth, and we cannot do that. But if yes, I would hope that it would be F sharp 10. Yeah.
Yeah, that's also just like taking a step back, a something interesting to know. Like you do all this work, then you hope it gets in there. There's understanding if it isn't, and then it might just land like exactly in 1 year. So that's also a very much of a patience game that you're playing here. So we
Yeah,
also just want to.
but I mean, I've been with it already for half a year, so I will also survive that next half or
I
three
know, I know, I
quarters.
know, but it still is very admirable how many patients you have to
Yeah.
pour into this. So compliment you on that. All right, taking one last look at the chat. I think we had all the questions. The YouTube chat as well. Any last remarks?
I will have a remark. I just wanted to express my opinion on the whole session, so not to the PR itself. So I don't know if now is the right time or like even a bit later.
Go for it. Hi, Petter.
Oh yeah, I've been sitting here like for all this time.
I know,
Well,
I know.
yeah. No. First of all, thanks a lot. Well, mostly for the patience and doing all this work. That's like a big deal. It's a big thing, and it's like a wanted thing in the community. So like, thank you for this. I wanted to share like the maintainer's perspective. I don't want to speak for the whole team because like I'm not the whole team and we have different perspectives. So I shared a bit of the like feedback on the PR itself. Like the thing with the whole like development cycle is that like there is a F# compiler, then there is like a F# language, and we as maintainers of the F# compiler are also seen as like language maintainers, which are a bit like orthogonal things. So we as developers of the compiler, we are happier for some PRs and less happy for other PRs. Not unhappy, but like less enthusiastic. That PR that like would, speed things up like for the developers or like for like something for the editor, whatever editor, like those will improve our own life and we are happier and we like react sometimes like faster on that. So and on the other hand, there are PRs that are supposed to implement just like language features, so which technically just like add more things to the compiler that we should like think of, and that's totally valid. We also want that. It's just that we are more paranoid about that, and it's more about like finding the time and capacity to review that. I really like today's session, and I think we should do more of those because I look at the PR. I don't know that particular area well, so I would need to concentrate and understand and learn like all that you explained. But there are people in the community who want that, who have used this feature, who have like stumbled on the same like problems that you have. And like if they can take a look, then like that will be for me also, for me as a maintainer, a good signal. Okay, people who understand that, they looked at that, they asked the questions, they shared the concerns, they thought how to test that. I see this work being done there, and I'm much more like confident about like the whole thing brought in, and also happier for the community and so on. So therefore, I think this idea of like community reviews is generally incredible. That's pretty helpful. We have a few more PRs that like deserve this. I would personally think that we should do more and we should like structure them a bit more so that those are shorter and so that like they become more interactive, because you explained what you've done well, it's helpful. What misses a bit is actual like, actual feedback. So we didn't have like much questions from the community. Hey, like, have you thought about this case? Have you tested this? Have you like tested that? So I imagine we could do those sessions a bit like shorter on the descriptive side and a bit longer on the interactive part of it. As in like, hey, what have you tried? And what cases have you thought of? So that would be beneficial because that would actually like produce some output for the PR, something that you can like work on now, because now the ball is still on the side of like community on us, it's still on us all to look at that and give you feedback. If these sessions could produce already some feedback for you that you could like work on whenever you have time, that will be like even more valuable. So that's just my opinion on how these community reviews can go in the future. So I was curious what happens today, because like we haven't done that yet. So, and that's my opinion here. I just wanted to share it.
Yeah, thank you.
That's interesting. I guess what you're kind of hinting at is that could be interesting if people already like check out Martin's PR, do a little build of the compiler, and then just really play with this up front and come up with some cases to discuss. Or
that would be extra awesome. But like, you know, even like general like high level questions about like the scenarios that can already like pop up during like such discussions. Basically, same idea as like what happens at the like language FS-lang suggestions discussions and so on. So like people just like may think of more factors in play, what can break, what can slow down, and so on, so that like create some kind of, you know, homework for you, Martin, in that case, so that like at least you can check some things and like ideally like test more things there. So
perhaps it would have needed then even two sessions, right? One with the general stuff and that background and explanation of the difficulties, and another one to do an actual code review.
That's up to the community. Like that's whatever we decide here, whatever amplifying F# decides on that. Like that can be multiple sessions. We can do like, well, definitely we can do like yet another session on the same PR, like we have capacity time and whatever. So that can be done like in 2 steps, in 2 meetings, or like in one, but like more structured and like kind of more quick. Also depends on the PR, how big is the PR and the feature and so on. So that also is a valid point.
Thanks for being here.
Sure. I wanted to represent the team here, so and share the perspective.
Well, what is your feeling then about those open questions and compatibility and surface area change? Does it have a chance?
Well, Kevin has already approved that, so like that has a chance. Like I'm not that well, like, you know, familiar with the area, so
But
I cannot really promise and make like my mind here. So
but
it's good.
I honestly thought that was a mistake, that he sent off the comments and didn't see that it was unapproved.
Maybe.
Yeah, let's see.
Yeah, I'll ask actually. No, I mean, technically, whatever is approved on the language level has the right to get in. It's really about the amount of paranoia we add to that. We have like different mechanisms how to like safety measures, and that starts with like flags and like defaults and so on. So like it always breaks down to the fact you're writing something new. So if there is kind of way to switch this off, that's fine, because like we are sort of safe from like regressions in a way. So if anything breaks, we can say, okay, like just switch this off. So but in some cases it's like easier to do, in some cases it's harder to do, in some cases it's worth it. So that's I think something to keep in mind. But like on a bigger picture, we have pulled in like much riskier things. It's like, it's not that we never pull in like breaking chains, we do. So that definitely has a chance, and all that stuff. It's more about like the patience, the testing, and so on. So I don't want to make promises, because again, as I say, I'm not the best person to talk about this particular feature. So but we started looking into that, and definitely it's more likely than not that it will get in. It's just like not certain.
And certainly still some work. I'm aware of that.
Sure.
All right, thanks. I suppose we can just give this a little rest and then see if we want to pick this up again, do another session. We'd be happy to facilitate. So yeah, I hope you got something out of this, Martin. We definitely enjoyed your breakdown of all of this. And I suppose we can wrap this little session up, and I wish you all a good weekend.
Thank you.
Yeah.
Thank you, Martin.
Bye.
Thanks. Bye.
Cheers.